Sponsored by Catchpoint, the leader in digital experience management.
Hi, I'm Chris Lopez, Technical Marketing Engineer for Catchpoint. And today, we're going to be taking a look at a specific type of Catchpoint synthetic test that can help you monitor and analyze systems that are built around IoT. Now, IoT is obviously a huge category. So in this case, we're going to be only taking a look at systems that employ Message Queuing Telemetry Transport Protocol, or MQTT for short. MQTT was designed in 1999 to ensure energy-efficient, data-minimal communication between devices, especially when communication and access to those devices was limited, like in the case of industrial machines. 20 years later, we're seeing it employed in a lot of IoT architecture because it is very good at scaling with a lot of users and also treating data like a premium. Catchpoint has a dedicated test for the MQTT publish-subscribe architecture, and over the course of this video, we're going to cover what MQTT is, why it's useful, and how to design and deploy an MQTT test inside of Catchpoint. Let's hop in.
So before we dive into any details, let's start with this. What do oil rig satellites, Facebook Messenger, Casso kitchen appliances, and Germany's trains have in common? Well, they all implement MQTT to ensure reliable IoT communication. To understand why they use this over, say, implementing an HTTP-based system, let's look at a real-life example. So let's say I'm a company like Matternet, right? That's a startup that uses drones to transport medical supplies between hospitals and testing labs. In order to get this kind of system approved, I would need to prove that all of my devices are accessible in real time, and that I can pull things like drone status and positions whenever I needed to. If I wanted to build a monitoring system like that with HTTP, it would quickly get overwhelmed as the size of my drone fleet expands, or at the very least, come with a pretty high capex. If I base my monitoring system in HTTP, each of those drones would need to individually connect to a server, and that server is maintaining a lot of simultaneous connections. That's going to consume a lot of data and energy, and that's something you don't want for your drones flying hundreds of feet above the ground. The same principle is also going to apply to mobile applications that don't want to be a battery hog for the user's phone. An MQTT-based system instead uses a publish-subscribe architecture, and this relies on a third-party system called a broker to deliver messages between clients. This allows communication to happen asynchronously, as everyone just checks in with the broker when they need to send or receive messages, or as we say here, publish and subscribe. A system like this is designed for minimal data and energy consumption, and it's not limited to a fringe use case like a fleet of drones. MQTT is a standout protocol for systems and services that need to deal with a lot of users. It eliminates vulnerable and unsecured client connections, it scales to thousands of devices, it tracks connection states, and it reduces network strain. And that's why you're using it for your IoT-related system or service, whatever it may be. Now that you understand MQTT a little better and how that relates to IoT systems and applications, let's talk about monitoring your MQTT-based system inside of Catchpoint. So here we are inside the Catchpoint SaaS platform. We're going to be conducting a synthetic test, meaning that one of Catchpoint's nodes is going to simulate web activity where we tell it to, and then it's going to return data about each hop of the journey. Keep in mind that MQTT is a lightweight protocol, and as such, we won't be getting such a large spread of granular network data for this kind of test, but there are a few distinct advantages to testing with Catchpoint that you'll see shortly. Now, in order to test this, I've set up my own MQTT broker in the cloud. So let's go ahead and fill in the following fields. For test location, you're going to fill in the URL of the server that your broker is hosted on. The node is where the synthetic test is being run from. In this case, I'm going to select a backbone node inside of Boston. Since this traffic is headed to the cloud, I'll need to run this test from a backbone node if I want to analyze the actual user experience. Now, the Catchpoint node is going to have to authenticate to your broker, so you'd select the appropriate level of security that you have here. Then you'd fill in your username and password, and then also put the username field in client ID, like so. And then we're going to fill in the fields below. The Catchpoint node is going to publish a new topic with a specific message that I define here, and then subscribe to messages from an existing topic, which you may remember are the functions of the broker now. It's the middleman between the client and the server. Now let's run it. Since this is a lightweight protocol, we should get the results pretty quickly. And with this, I not only see that my MQTT broker is active, but I can publish new topics and subscribe to messages that I've stated above. Also, if your device uses a specific port for encrypted or unencrypted traffic, you'll need to put that into the test location, otherwise you're going to get an instant connection failure. This is more useful than just a basic keep alive or heartbeat test that you might otherwise run, because Catchpoint is allowing us to test our publish and subscribe topics. Your IoT system will likely need specified topics that your client devices can subscribe to. Also, since IoT usually extends to users on mobile devices, you'll be able to run these synthetic tests from cell nodes or last mile nodes, factors that could easily come into play when dealing with thousands of users at once. It's an effective way to directly test your user experience, especially when dealing with rollout or investigating specific problem areas. Here, we're looking at the results of an MQTT test that's been running for a while, and this is where the full value of Catchpoint becomes clearer. We're able to point out both individual results and overall experience of these tests, depending on whether I pick trending or scatterplot, which you see have been run from nodes all around the world. As I scroll down, we'll get to see our Network Insights feature at work, as it traces the hops from each of the synthetic test nodes to the destination, giving you hop-by-hop data along the way. And with that, you now know how to test your MQTT-based services and applications. That's all we got for today, so thanks for stopping by. I'll see you next time.
Sponsored by Catchpoint, the leader in digital experience management.